Hey grade 10s, so welcome to our factoring lesson today. Sorry I'm not able to be with you. Now remember, factoring is really the opposite of expansion. So in the image you see below, if I'm talking about the product of binomials, so we're going to go over expanding first. You'll notice though that I have a fabulous comic for you. It says 253 is 11 times 23. What? I'm factoring the time. Because notice it says 253. So just a little funny blurb there. But again, when I'm expanding, first, outside, inside, last. You kind of make these lobster claws. So first, 3x times 2x, 6x squared. Outside, that's 15x. Inside, 4x. And lastly, plus 10. Now you're always going to get two terms in the middle that you want to collect and simplify. So I write my final answer as 6x squared plus 19x plus 10, and I leave it. Okay. What I'd like you to do is just challenge yourselves, pause the video, and expand and simplify the following expressions. So pause it and give it a go. This one would be x squared minus 4x plus 2x minus 8, x squared minus 2x subtract 8, and the last one, 2s squared plus 8s plus 2rs plus 12r. You'll notice in this last example, it cannot be simplified any further. Okay. So our first step in factoring, remember reverse FOIL, is by looking for a common factor. So I'm looking for something common in both terms, and then I want to divide the term outside. So in this example, 10x squared plus 35x, I can take a 5 out as well as an x. If I do this, I'm left with 2x plus 7. I cannot simplify that any further. That's the end. In the next example, 3 terms, 6x squared, 9x, 15, the only thing they have in common is the term 3. So I can take a 3 out of all of these terms. This becomes 2x squared minus 3x plus 5. I look again, nothing can be taken out. I know that's fine. In the last term, my common factor is a 4ab. Notice I can take an ab out of each term. I'm left with 3a minus 2b. I can't factor any further, so I'm done. In general, we don't do a lot of common factoring. We focus more on factoring trinomials. The word trinomial means that there are 3 terms. Okay, so again, this should be familiar to you. Notice that in this form, the a value in front of the x is a 1. So remember, if it's not there, it's 1. In order to do this, I use something called the X box, mostly because I think it's fun to say. So what I do, it's a sum and product box, and I'll do it out here on the side first. I want to say what multiplies to A times C, okay, so that's a multiply sign, and what adds to B. So here in the first example, I say what multiplies A times C, 1 times 8 is 8, and what adds to 6. So multiplies to 8 adds to 6, 4, and 2. So I can break it up directly into my factors x plus 4, x plus 2. Done. Now if I wanted to check, all I do is you expand. Right? X squared plus 2x plus 4x plus 8, and you see that in the end I'm left with the same value. So that's the check. I know I'm right. You do not have to do a check for these questions. We'll do another X box. What multiplies to 9? 1 times 9 adds to 6. 3 and 3. Into your factors, x plus 3, x plus 3. Now this is not fully simplified because I can go one step further. X plus 3 all squared. So please make sure you simplify it. This is usually a test question because of that last example. A little bit harder here. So using our X box, what multiplies to 54 adds to negative 15. Okay? So thinking that through, 9 and 6. So negative 9, negative 6, x minus 9, x minus 6 is my factors. The last one, x box, what multiplies to negative 10, adds to negative 3, 5, negative 5, and positive 2. So this becomes x minus 5 and x plus 2. Again, your factors are coming right from these terms here, negative 5, positive 2. When you're ready and feeling pretty comfortable with that, flip the page. And we get to this form, factoring trinomials in the form ax plus by plus c, where the a value is a number. We're still going to use our x box. Remember what multiplies to a times c, and what adds to b. Okay, so we're still looking to factor in that way. What multiplies to 6 adds to 5, that's 6 and 1. What is different is you always want to split up the middle term. And then we common factor. I'll show you what that means. I take my middle term, the 5x, and I split it up. First off, I rewrite the 2x squared, but instead of writing, Instead of writing 5x, I use the 6 and the 1, plus 6x. Oh, and that should be 3 and 2. Sorry about that, folks. I wasn't really paying attention. What multiplies to 6 adds to 5 is 3 and 2. So this becomes 2x squared plus 2x plus 3x plus 3. So again, notice I split this term, the 5x, into the 2x and 3x. What I can do now is I look to common factor by grouping. So I look at the first two terms, and then I'll look at the second two terms. In the first two terms, I can take a 2x out. This becomes x plus 1. In the second two terms, I can take a 3 out, x plus 1. It's at this stage where you look to common factor. Okay. X plus 1 is a factor of both terms. So out front, I factor an x plus 1 out, and I'm left with the 2x plus 3. And that's our factored version. Do one more following along with me, and then you can try C and D on your own. So x box, what multiplies 3 times 2, so 6 adds to 5. Look again, that's 3 and 2. So we take our function and we rewrite it with a new middle term instead of 5x. 3x squared plus 3x plus 2x plus 2. So notice I'm keeping those end terms here. I common factor. I can take a 3x out of the first two terms, and I can take a 2x out of the additional two terms. I notice here I have that same common factor. So on the next line when I rewrite, x plus 1 times 3x plus 2 for my remainder. You can try C and D on your own. If you want to continue to follow along, no problemo. So here, what multiplies 4 times 9, so 36, and adds to 12, 6 and 6. Take your middle term, split it up. This becomes 4x squared plus 6x plus 6x plus 9. and I common factor the first two terms, 2x. I'm left with 2x plus 3. Here I can take a 3 out, 2x plus 3. And what you should be noticing is every single time you get a term that is the same. If this doesn't happen, go back, review. So we factor a 2x plus 3 out, and I'm also left with a 2x plus 3. And we know this trick, so there should be sirens going off in your head. This should be 2x plus 3 all squared. Okay, so that's an important step here. I'll put a little star because this is a good test question. Last one we'll do. What multiplies to 24? Oh, my pencil's not working. Adds to 11. 6 and 4 becomes 4x squared plus, I'm going to make that the 4 here, plus 4x plus 6x plus 6. Okay. I just realized we're saying what multiplies to 11. So I apologize once more. Sorry guys, it's the end of the day. What multiplies to 11? So adds to 11. That's going to be your 8 and 3, 8, 9, 10, 11. So we rewrite 4x squared, I apologize, plus 8x plus 3x plus 6, and common factor each term. I can take a 4x out, x plus 2. I can take a 3 out, x plus 2. And I get my final term, x plus 2 bracket 4x minus 3. Okay, and we're done. Again, it talks about here expanding. Verify your answer by expanding. You should always get the same answer. So there are a few difference of squares here. You can't actually read them, which is wonderful. So I'm just going to rewrite them on the screen for you. Okay. A difference of squares is a special case where you have a function that looks like a perfect square. So let's make this x squared minus 36. We'll make this 4x squared minus 25. I'm just kind of making these up. X plus 2 squared minus y squared. And the last one could be x squared minus 2x minus 1 all squared. Okay. To factor them, this becomes x minus 6, x plus 6. So a difference of squares always has the same term with a different symbol in the middle. It's the perfect square of both terms. The perfect square of 36 is 6. The perfect square of x squared is x. This term becomes 2x minus 5, 2x plus 5. The last one here, x plus 2 is my first term plus y. And notice I'm using big brackets. X plus 2 minus y. In this case, there's nothing that cancels, but it's important to keep the brackets, just because you'll see in the next example what can happen. If I go to factor this very last term, last question before your homework, first bracket, x, we'll make it plus 2x minus 1, x plus 2x minus 1. And you'll notice what has to happen. This becomes 3x minus 1 and 3x plus 1. Okay. Two different terms for different functions. Assigned work, it's the common factoring you see here. Common difference of squares. Which means you can maybe take out, doesn't matter which column, but questions on that